Hello, this is the fifth video in the core chemistry series. In our previous video, we covered the elements and their arrangement on the periodic table into such categories as alkali, alkaline earth metals, halogens, and noble gases. In this video, we will discuss atomic bonds and how reactions between elements create these molecules and compounds. When chemical bonds hold together two or more atoms, whether they are the same element or different, the bonded atoms are considered a molecule. An example of a molecule would be O2, which occurs when two oxygen atoms bond together. Compounds occur when two different kinds of atoms bond together. The bond H2O is considered both a molecule and a compound. Not all molecules are compounds, but all compounds are molecules. The formulas used to represent molecules and compounds have been used for over 200 years. To write the formula for a molecule or compound, you use the symbols of the atom followed by the number of atoms in that molecule or compound. For example, you may have seen the formula for water, H2O. The subscript 2 means that there are two hydrogen atoms. The oxygen has no number beside it, meaning that there is a single oxygen atom in the molecule. This means that for every two hydrogen atoms, there is a single oxygen atom in water. If more than one of any particular molecule is present, you would note the number of molecules in front of your formula. You would write two water molecules as 2H2O. Now you have four hydrogen atoms and two oxygen atoms. Two different types of compounds are molecular compounds and non-molecular compounds. Molecular compounds have clear bonds between individual atoms. Unlike molecular compounds, non-molecular compounds do not have clear bonds to one another. Instead, the atoms link themselves together, arranging into a geometric structure called a crystal. The most common form of a non-molecular compound occurs when atoms of opposite charges attract. A charged atom occurs when an atom has gained or lost electrons. Charged atoms are called ions. Because of this, compounds formed due to the attraction of opposite charges are called ionic compounds. Not all crystalline structures are ionic compounds. Diamonds and ice both hold the geometric shape of crystals but have no charged ions. The diamond has bonds similar to a molecule that are so strong that the diamond is the hardest of all known substances. Ice is made up of interlocking atoms. However, it only forms this crystal shape with the right temperature and pressure. It is important to realize that a compound and a mixture are not the same thing. Mixing elements does not mean a compound is created. For a compound to form, atoms have to form a chemical bond between them. This means compounds need a chemical process to separate the individual elements. Because of this, mixtures are much easier to separate than compounds. To separate mixtures, you need an action which affects the involved substances differently. Evaporation and dissolving are two common methods used to separate mixtures. In a chemical reaction, atoms bond, which means that the original structure of the compounds or elements involved have completely rearranged to form a new substance. A reaction can totally change a substance. An example of this complete change caused by a reaction is sodium and chlorine. One is gray, one is yellow, one is metal, one is gas. Both are extremely poisonous and reactive, especially with water. However, when they combine, they form sodium chloride, or table salt, which is necessary to the human diet, white, soluble, and very stable. Combustion is one of the most common methods of a chemical reaction. It occurs when substances react very quickly with each other, such as burning wood. Your body also uses chemical reactions to break down food and absorb energy. In this video, we have covered molecules, compounds, molecular versus non-molecular compounds, mixtures versus compounds, and reactions. Thank you so much for watching.
Bingoa.